Everybody from the Johnson Space Center in Houston, welcome to today's mission status briefing. It's been a busy day for the SpaceX and NASA teams, and here to give us an update on the flight of the Dragon so far is Holly Ridings, who is the lead NASA flight director. We're also joined by John Caloras from the SpaceX facility there in Hawthorne, California. So we'll get started with Holly.
All right, well, good morning, everyone. Today is a really great day to come and talk to you because it's been very, very successful up to this point. Today we performed our first joint operations with the team at SpaceX in Hawthorne, California. And this is really something we'd been training for many years and really looking forward to. And we're excited that this first operation jointly with that team went as well as it did. So we had a very successful fly under, where Dragon flew under the space station about 2.5 kilometers below the space station. Again, this was our first joint operation. We had several activities that we wanted specifically to accomplish with this fly under. One of those was communication between the Dragon and the space station. We were able to establish that successfully, check out that link both from the crew on board and the ground teams. And so that was very, very positive. One of the capabilities that we needed to perform the rendezvous and the capture tomorrow. We also were able to kind of shake out our process of working together. Again, I mentioned we'd been training and practicing that for many years, but doing it for the first time with two dynamic spacecraft flying very close together. You always want to make sure that you're going to be able to work as you trained, and I'll tell you that it went very, very smoothly. It felt exactly like our training. The teams communicated about all of the activities that were performed today in a lot of detail and showed a lot of understanding and communication. The other thing we did today, certainly on the space station side, we worked some with our crew as they prepared for the rendezvous and capture tomorrow. Those activities were some training activities, doing a kind of a last run through with the SSRMS, the robotic arm that's in the position it will be that they use to capture the Dragon tomorrow. And so they were doing some final training runs with the robotic arm, and they were actually also setting up their displays, their cameras, checking out the crew command panel, which again is how they communicate from a command standpoint with the Dragon. And we also were able to see the Dragon as it flew under. The crew reported to us a tally-ho with the Dragon. The Dragon has a strobe light that was turned on, and as the Dragon passed below the space station, the crew reported they were able to see that light, that strobe light, and then our station cameras captured the Dragon as well, which is the picture that you're seeing on display here, our downlink from our external station cameras. So all of those things wrapped up into, as I mentioned at the beginning, a very successful day, a great day in space, and certainly from the NASA side, we are excited about how the mission is going so far. And so with that, I'd like to hand it over to my colleague and my counterpart at SpaceX, the Dragon Mission Director, John Caloras.
Good morning. Thanks, Holly. Yes, it's a very exciting day for us at SpaceX. As Holly said, we performed the flyby at 2.5 kilometers below station. All Dragon systems checked out. We look good. We're currently past station now, preparing to fly up and over station overnight and prepare for berthing. Dragons go for berthing day tomorrow, and right now we're looking good across the board.
Okay, we'll take some questions starting here in Houston first, and then we'll go to the phone lines. And since we have Holly here and John out there in California, we ask that you direct your question and let us know who you're asking it of. So we'll start over here with Mark.
Thank you, Mark Carreau for Aviation Week. This is for Holly Riding. Can you sort of compare what unfolded today with what you kind of expected or anticipated, even with all of the training? And though today was a success, do you feel like you need to caution us that tomorrow is still pretty sporting, or do you feel more confident based on what happened today?
Okay, so in terms of the training, obviously the mission's really got two large components. This was the first one, the fly under. The second is the rendezvous capture berthing activity, which will take place tomorrow. We had practiced and trained both of those components, and I'll tell you today went really very close to how we had trained it. There was no major deviations from our pre-flight plan, and really nothing that we saw that we had not discussed at some point in time prior to the mission. So when you perform operations with the real vehicle, it's always a little bit more interesting in terms of you learn things, you see the real data, but all of the pre-flight planning, our flight rules, our procedures, everything held up under the scrutiny of really flying in space with the Dragon for the first time. In terms of how I feel about tomorrow, certainly this is a demonstration flight, a test flight, as we've been saying, and to get through this first piece of it obviously makes you feel positive, but in terms of the activities tomorrow, there's still a lot of really new things that the teams need to perform, and the vehicles, frankly, need to perform. And so, although today was successful, this is still definitely a demonstration flight and a test flight.
Thank you very much. I had a follow-up question. During the activities today, there were some difficulties on the station with the console monitors, and I realize there's a backup in the lab. I just wonder if there was any after action that's required today and overnight before you go forth tomorrow based on what happened today with the monitors, or if they're all good to go now.
So the short answer is they're all back in the nominal configuration and ready for tomorrow. Specifically, we had one of the monitors at the robotic workstation that kind of froze. That happens periodically, so we had to go through a reboot process, just like you'd reboot your laptop. And so it comes back up. The crew then did use that monitor for various activities, and so we know it's functioning properly. This, again, is a standard thing we see with a lot of robotic activities. They also were performing a calibration of some of our external cameras so that those cameras communicate with the information on those monitors very accurately tomorrow. And so that process took a little bit longer than expected, just because it's the first time we'd really done it for this specific vehicle. We have done that calibration before for other visiting vehicle HCV as an example. So it's just been a while since we'd actually executed that activity. But again, we got through it, we got the data we needed, and everything is set up and ready to go for tomorrow.
Philip.
Philip Sloss with NASASpaceflight.com. I just had a question about the timing for today and then also for tomorrow. The HA2 burn today was about an hour behind the I guess the timeline that we'd seen. Why was that, and is that going to propagate out for tomorrow's rendezvous as well? Thanks.
Okay, so the answer is it's not going to propagate for tomorrow's rendezvous. We expect the rendezvous to be on time for our pre-flight plan. And then I think for the first part of your question, I'll actually let John answer.
Yes, thank you. So that's correct. We ran about 50 minutes from the nominal timeline from the launch. Once we inserted into orbit from Falcon 9, we adjusted some burns in order to meet the height adjust 2 burn time as close to 0700 UTC as possible. And working with Holly's team, we decided it was 0747 was our target, and we hit it about 0752. So on the replan, we're actually very close.
Yeah, and I'll follow up by saying, again, as John said, that was really a decision we made just with managing the mission. We had a pre-flight prediction, and then after the Dragon got on orbit and we were able to watch how it was flying, it made a little more sense to us to start a little bit later in the crew day and make sure we had a lot of really solid time to involve them. And so we had a discussion and like I said, targeted that a little bit later than we'd planned pre-flight. As they fly around, they will then target our pre-flight time. Tomorrow, we don't have the luxury of starting a little bit later because it's a really long day for the crew, and so we expect to be right back on our pre-flight plan tomorrow.
Okay, Robert.
Robert Perlin with CollectSpace.com with a question for Holly. Sort of working off of that, if you do run into delays tomorrow, is there a hard time where you would either have to call an end to an attempt to a berthing, or if you were grappled, when you would have to call and say that it has to remain on the arm until the next day to be berthed?
Yeah, so yes, the short answer is yes, and really the biggest consideration is you're kind of managing your crew timeline. You know, they are a resource and a consumable. If you think about it, they're going to be working very hard all day. So if we were to have challenges as we did the rendezvous, there is certainly the option to go ahead and put the Dragon in what we call an overnight park position, where it stays on the arm overnight and you finish up the berthing. That's an analyzed configuration. It's a pre-planned configuration. Certainly, I know everybody would be much more excited if the Dragon was berthed, but if we need to do that, that's something we've discussed. We have all the procedures, and it's similar to plans for the other visiting vehicles. So if you're looking for a hard limit, it's really based on the crew day and how much we need to work them. So there's a fair amount of margin beyond the actual capture time, on the order of several hours, that we'll be able to go ahead and work through any challenges and still have enough time to get berthed tomorrow. And then even after that, we've got this pre-planned activity, this overnight park, which we could use if we needed to.
And just a quick follow-up on that, if it did come push to shove, would that be something that, since it's based on crew time, that Don Pettit and the others could call down and say, no, we want to work into the night, and you'd allow them?
So you're familiar with some of our crews, and they love to work. It's my job and John's job working with me to protect them, because they are a resource, so we don't want to burn them out in one day. I fully expect them to call and say, hey, we'd like to keep going, but it's our job as a joint team to know when we've done as much work as we need to today and make the decision that we'll just go to the next day and preserve really the team as a resource to make sure we can make the right decisions.
Okay. Do you guys have any questions over here? No? Okay, let's go to the phone lines. I believe that we have Charles Atkinson.
Good morning, Charles Atkinson, Examiner.com. For John, what is the current fuel level aboard Dragon, and how does it compare with the pre-flight numbers pre-docking?
Certainly. So currently, we are tracking above our pre-flight plan. We're about 36 kilograms, if you'd like an exact number, above our pre-flight plan, and we're looking very good. It's a fairly consistent profile to the plan now for the re-rendezvous and berthing, so we should be good. And this protects us if we need to extend, or as Holly said, as a test flight, if we need to take more time and come back around a second time.
Okay, and John, one more. Unlike today, will the cameras aboard Dragon allow viewers here on the ground to view the space station pre-docking?
So the cameras will be available. We use them, we need to be over a ground station when we receive video. The cameras will be, or rather the video system will be connected to our thermal imagers. So we will have video of station, but it will be in the IR spectrum, the infrared spectrum.
Okay, and will that be available on NASA TV?
We are feeding video to NASA, and I'll be working with Holly when that's available.
Okay, and Holly, my final one is May 31st the absolute final day Dragon can stay docked to station?
Well, let's see, May 31st is our nominally planned departure day. The Dragon has other landing opportunities, re-entry and deorbit opportunities, and John could tell you some of the specific dates beyond that for Dragon. On the space station side, at the beginning of June, we're headed into a high beta time period for about 10 or so days, and so we'd like to not do any dynamic vehicle activities, dockings, undockings, berthings, unberthings in that time period. So May 31st is nominal. We've got a couple of days after that to work with, and then the Dragon, if needed to, could stay even longer than that.
Very much.
Okay. How about Jason with Wired Magazine? No.
Hi, a question for John. Want to know a little bit more detail about the rehearsals and simulations beforehand. If it's possible to get any kind of idea of how much time that you worked with NASA on some of these simulations, and then in particular, were there any things in the simulation for this next stage, tomorrow's part of the mission, that were ever problematic and is something that you're really looking forward to, I guess, a point getting past beyond the actual birthing itself?
Certainly. I've been working with NASA on this mission specifically for a little over 5 years now. We've been simulating for almost 3 years in various stages, but really the main thrust of our simulations have been over the past year and a half. We've conducted almost 20 joint simulations with NASA and over 40 simulations internally here to SpaceX among the 4 shifts of operators we have working. So we've been working it very hard. We fly by the mantra of train like you fly and then fly like you train. And so far the mission has been proceeding just like a regular simulation, so we're very pleased with that. Tomorrow, as Holly said, it is a test flight, so I don't want to jinx myself and say what I can expect and then see something different. But right now the mission is looking just like our simulation, so we're fortunate there, and I'm not expecting anything that we haven't seen in a simulation.
Were there any things in the simulation that that was sort of that hump that you had to get past, or that hump that caused any issues that you're going to take a breath once it's over tomorrow?
We use the simulations, and as I said, we've been simulating for a number of years. We use them to iron out work on the hardware as well as in the operation. So it's one of those nice things about SpaceX because of our development process, and we're all under one roof here at Hawthorne. When we find something in a simulation, we'd go back to the hardware people and talk to them about it and be able to iterate back and forth. So I'm not expecting anything that the teams at least aren't prepared for. We have a very crack team. There's always a chance of something that we haven't simulated coming up, but we also have hardware in the loop here in Hawthorne that we can run against before we do anything on the spacecraft. So again, I'm very confident, and our simulation supervisors have been, I think they've enjoyed torturing us with very unique scenarios, so we're looking forward to birthing day tomorrow.
Thank you.
Okay. Let's go to Marcia Dunn, Associated Press.
Yes, hi, good morning. I have a question for John over at SpaceX. What was the atmosphere, the mood like when you completed the operation this morning with such finesse? And I'm wondering, what kind of a mood does that put you in for tomorrow? Are most of the nerves gone now that you did so well?
It definitely does help with the confidence. Again, achieving the C2 mission objectives, the original C2 mission objectives today, is a big confidence boost. Everyone's very excited. We wanted to make sure everyone got to bed, so they're well rested for tomorrow. But it's exciting to be, an American and part of the of putting American spacecraft into orbit, and we're very proud right now.
Thank you very much.
All right. Clara with Space.com.
Yeah, hi. My question is for Holly, and I'm wondering, when was the decision to give the official go-ahead for birthing made, and what was the process of decision-making there? Was it just a straightforward thing?
Let's see, so it's actually a series of decisions. So when we talk about the fly under today, we did sort of step one in that process. So we did sort of an official poll, both at the control center in Hawthorne and then the one here in Houston, in order to bring the Dragon up to that 2.5 kilometers below the space station for the fly under. As Dragon flies around the space station over about the next 20 to 22 hours, there's a series of those decision points, and at each one of those you're checking really the health of both spacecrafts and make sure you're still in what you expected pre-flight in terms of your performance and your systems. And so you do that overnight, and then you'll start into your rendezvous sequence. I think of it, it basically starts at the point where we were. We call it the HA2, the height adjust 2 burn. That's the burn where we started the fly under the day. Instead of going under at 2.5, we'll continue on up towards the space station, and you can see each in the graphic that they just put up for me. You can see each of the kind of brown, maybe red colored dots is another height adjust maneuver. So again, you're turning on the Dragon engines, the team in Hawthorne is, and moving the Dragon closer to the space station. And each one of those points, again, has a pole, has a go in our nomenclature, and you're doing that at 2.5, you're doing that at 1.4. We do that again several times after the Dragon is, again, on the R-bar, which is kind of that space below the space station if you drew that direct line from the space station down to the center of the Earth. And so the final go for berthing is actually very close to the space station, so 10 meters. We call that the capture point. And so after you've crossed through all the gates leading up to that point with an increasing number of systems that you need to be working correctly, then you give that final go. Again, that's a joint poll between John's team and my team here in Houston. And then after that, you really turn it over to the crew. You tell them your go for capture. They take both spacecrafts into a free drift, again, so that the thrusters do not fire on either spacecraft, and reach out and capture Dragon with the arm. So when we talk about there having been a go for berthing, it's really, again, a series of activities, the last one being right when Dragon is very close to the space station. And that'll occur about 7 a.m. Central Time tomorrow. Again, roughly, because we've got a lot of data to look at and activities to perform, but that's the rough time where that last go for berthing will occur.
Thank you.
Okay. Brian Berger of Space News. Brian, are you there? Okay, let's skip to Brendan McGeary with Bloomberg.
Thanks, guys. Just, I guess, 3 parts here, hopefully pretty brief, though. Can you just summarize in brief what happened this morning? Clearly the fly under is sort of a milestone, but, you know, they mentioned the strobe light there. Just a few more just highlights on what exactly you guys accomplished this morning. 2, where things, are going, I guess, throughout the day. You mentioned sounds like the race tack, the circling is now what's underway. And then 3, just confirm for me the scheduled berthing time for tomorrow.
Okay, well, let's see. The first part, I actually was going to ask John if he wanted, from his perspective, to give you the highlights of the fly under, since it was his spacecraft we were seeing for the first time.
Certainly. So right before the flyby, yesterday and the day before, we performed some spacecraft checkouts, which included an abort demonstration, and then our GPS demonstration of Dragon navigating off GPS by itself, and then a free drift demonstration. And free drift is where we shut down all the thrusters, and we do that at that 10-meter point that Holly just mentioned, prior to being grappled by the arm. So we demonstrated all those, and we're ready for flyby today. For today, our major mission objectives were to prove first our COTS UHF communications unit, also known as Cuckoo, was able to close a link out to Dragon. Cuckoo allows us to communicate between ISS and Dragon at very close ranges. We're expecting roughly between 23 and 28 kilometers. We were very fortunate today. We exceeded those going, I'd say, in excess of 90 kilometers. So again, very fortunate. When you asked what were one of those points in the mission I'm kind of holding on to, it was that, and that was a great thing for us. So our Cuckoo unit allows the crew to command Dragon, and we proved that that link works, and it also allows Dragon to know exactly where ISS is by using ISS's GPS state. So as we came in, we performed the height adjust and co-elliptic 2 burns, and we flew understation, performed some Cuckoo operations, and then once we confirmed GPS was working, the crew sent the crew from the crew command panel, which is a panel connected to Cuckoo, the strobe on command. And that was really to test that the crew can send a command to Dragon, and something that was benign. And we saw that the strobes were indeed on. And then we continued operations, and then the crew, through the same panel, selected the strobes off. So we have proven that that both Dragon can already navigate within close proximity of station, and that the crew can command Dragon. So 2 very important mission points for today.
Let's see, so I'll pick up with the rest of your question and add just a few points. So on the space station side, in order to do the communication with Dragon, the UHF communication, we put the space station in a very specific attitude, which requires us to make sure our solar arrays are configured properly. So the type of things we do for other visiting vehicles, we also perform for Dragon. And there's a box on the space station, the Cuckoo box, SpaceX built and flew up, that communicates with its partner box on the Dragon. And so we made sure that was working correctly on the space station side. John mentioned that we gathered some relative navigation data. So it's very important for us tomorrow to make sure that that relative navigation, we call it our GPS data, is accurate. We did not use it for navigating today as we flew under, but we gathered data, and there's a team of experts at NASA and SpaceX, actually as we speak, pouring through that data to make sure it's all working correctly for when we need it tomorrow as we approach closer into the space station. And so that's a component that's very important to us, that we go through that thorough review and understand that tomorrow when we do use that capability, that the navigation will work correctly. Let's see, you asked too, what else was going on today? So one thing was the data review. The Dragon will perform a series of burns as it goes around the space station. So the joint operations between the control team, operations team here and in Hawthorne, again, continues all on the next 2 shifts before we report back for duty tomorrow. Again, just making sure that the Dragon can end up in exactly the right place to start the rendezvous tomorrow. The crew for the rest of the day today will be continuing on with their preparation. They've got some conferences to understand and get ready for the Dragon cargo operations, which of course is one of the primary objectives of this test, of this demonstration flight, to bring up and show that the crew can transfer cargo in and out of Dragon. And so they'll be doing some preparation for that activity, those activities later in the week and into next week for the rest of their day on orbit today. And I think your final question was berthing time. So I mentioned earlier, capture was going to be roughly 700, and I'm doing it in Central Daylight Time. Berthing's 10:30. It's right about 10:30 Central Time is where it's timeline, and of course it can move a little bit earlier or later depending on how much time we need to evaluate the spacecraft as it sits below station in that R-bar location. But 10:30 is a rough nominal time.
Thank you.
All right, Irene Klotz with Reuters.
Thanks, Josh. I had a couple questions for John. First of all, is your title also a flight director, or what's the SpaceX designation for you? And also, was there anything in the test today that you're going to use to tweak anything for tomorrow?
Certainly. So first at SpaceX, we use the term mission director, and I'm the lead mission director for the Dragon C2+ mission. We use the term mission director just to distinguish between mission and flight director calls while we're on communications with them, with NASA. Secondly, there's nothing that we would necessarily tweak. One thing, because Cuckoo closed so far out, I'm feeling very confident that some of our contingency procedures that we were looking to do to getting closer will not be necessary. So Dragon looks good, and we don't expect any tweaking.
Thanks. And the other question I had is just kind of a technical curiosity about why you use the video system connected to a thermal imager, what that gives you beyond optical spectrum. Thank you.
Oh, certainly. So we actually have a number of video cameras on Dragon, as well as 2 thermal imagers. We have 2 video cameras that point out at each solar array. We use that to check out the arrays, as well as get some pretty stunning views of the Earth. I believe we'll be posting those. And then we have a 3rd camera that's inside the capsule itself. So when the crew ingresses Dragon, we'll be able to get some pretty good video of that. The 2 thermal imagers are part of our proximity system. So we use the thermal imagers in coordination with our 2 LiDARs to give us exact range and range rates to the International Space Station as we're approaching from the R-bar, as Holly had mentioned. Because they're thermal imagers, we're able to hook them up via video switch to also get video from them. So it's kind of a bonus. There's no technical reason why we need infrared video coming to the ground.
Okay, I guess that's it from Irene. James Dean, Florida Today.
Hi, thanks very much. John, for a couple of questions. I think we've seen obviously a number of vehicles come and go from the station. Could you just remind us why, from your perspective, if you're able to berth, it would be such a big deal and such a historic event?
Certainly. There are a number of unique items of Dragon that other vehicles don't have, the biggest one being our ability to return large amounts of cargo from orbit. With the retirement of the shuttle, now there's only one other vehicle, the Soyuz, the crew-carrying Soyuz, that can return mainly crew members and a small amount of cargo back to Earth. So Dragon has a very significant amount of cargo it can bring back. Furthermore, after this mission, we're on contract for at least 12 more missions to the International Space Station. And so we're looking to provide regular services, again, kind of at a faster rate than some of the other vehicles.
Thanks. And is it fair to say that your activity tomorrow is much more difficult than what you went through today? Obviously, understanding that you had to get through these steps first, but I mean, looking to what's next, is the Dragon maneuvers, do they require much more precision, and are they more challenging to the software systems that you spend so much time working on, or could you sort of characterize that?
Yeah, I'd say generically speaking, it is definitely a more intense day tomorrow. Flyby today allowed us to check out a lot of systems and retire a lot of risk for tomorrow's flight. We were also able to get some additional objectives where we powered up the LiDARs and the thermal imagers, which we use for very close range navigation to the space station, and those checked out good. So again, we retired a lot of risk for tomorrow, but just like what you said, there's more fine maneuvering. Dragon has a lot of automatic systems on board to protect station and Dragon itself from if we see a malfunction. We haven't seen anything that would require those right now, but it is the first time we're using them, so it is a test flight, and we are being cautiously optimistic.
Thank you.
All right, thanks, James. Last one, Jay Barber with NBC. Jay, are you there? Okay. Are there any follow-ups here in Houston? Anybody? Okay. Before we step away, let's take a look at the remainder of our programming schedule for NASA television. We will have ISS update later on today at 10 o'clock at the top of the hour, 10 Central, 11 o'clock Eastern. We will return bright and early tomorrow morning at 1 a.m. Central Time, 2 a.m. Eastern Time for live coverage of the grapple and berthing of Dragon, and we will stay on the air throughout the entire operation. At noon Central Time, we'll have a mission status briefing to take a look at the day's activities and how things have gone. And then on Saturday morning, we will be on the air at 4:30 a.m. Central Time, 5:30 a.m. Eastern Time for coverage of the hatch opening. And then later on that day at 10:25 a.m. Central Time, 11:25 a.m. Eastern Time, we'll have a crew news conference with some members of Expedition 31 as they talk about their experiences and their reflections of the milestone of this mission. So that'll wrap it up for us. As a reminder, ISS Update is up next here on NASA Television at the top of the hour, 10 a.m. Central Time, 11 a.m. Eastern Time. We thank you for joining us.